Ever wonder how much a $5 Starbucks really costs you in the long run? Or how much letting that cash sit in your checking account is really going to cost you as the years go by? How about the true cost of credit cards and why? Despite all the people who default on them, they're still powerhouse conglomerates, these credit card companies. You might be surprised at the answer. Do you have a hawk's eye on your retirement portfolio and find encouragement through your own financial analysis of that portfolio? My name is Jalal Sultani, and this is my first video tutorial on the 10B2I Financial Calculator. You can find this app in the Android App Store or the Apple App Store. It kind of looks like this. It's by In a Day Development. For a little bit more information, you can find them at inadaydevelopment.com. My name is Jalal Sultani, and I'm an average Joe. I work as an accountant and office manager. I do a little bit of payroll, among other things, and I really have an avid interest in personal finance. I recently joined the Dominate Your Debt group, so shout out to all those debt dominators out there. And I first learned about this calculator as a tool for real estate investors. That's the industry I'm in. Apparently it's a highly valued tool among them. When I sat in a workshop, I discovered that the same functions could really be applied to personal finance, as you'll see. Our lives do change, and so do the variables in our finances. The intent of this video is to share the idea behind using the financial calculator to gain a grasp on financial success. Albert Einstein once said, "Compound interest is the eighth wonder of the world. He who understands it earns it. He who doesn't pays it." Although it can be purchased as an actual calculator, the smartphone is available digitally, and you can find some versions on the web as well. So let's get started. I'm going to maximize this. I'm going to just go ahead and explain the 5 simple buttons we're going to be using here. All along the top, N is the number of periods in the calculation. It is the loan or investment term of 10 to 30 years, or however long you want, in months. So we can have 340 months, for example. Let's go ahead and clear this out. So we can have like 300 months. Once you hit the number and then the N, that saves it right there. Next is the interest per year. It's the annualized interest rate right here. So you can do like, 15, let's say 15%. Okay. And then the PV stands for present value, or starting balance of your investment in some of our upcoming examples. So you could go like $1,000. And payment. That is how much additional funds you're going to be adding or withdrawing over the course of each period. So let's say you wanted to take out $100. Okay, in this case, when you're investing, you're going to have it in negatives, like that. Okay, and future value, this is basically what the end goal is. What kind of a future value do you want? It allows us to calculate what we want the future balance to be at the end of the last period in the scenario. So we could have it be 0, or we could have it be $1 million. Ideally, you're going to fill out 4 of the 5 of any of these with information and solve for the 5th, for example. So let's go ahead and jump into some great examples. Let's look at the opportunity cost section here. Let's look at the effect of $100,000 from inflation in 30 years. So I did a little bit of the homework. Inflation. And here we can see inflation every year, but I'm really focused on, let's say, the last 10 years, just kind of where it's stabled out. I've got an average inflation about 2.63%. So we'll use that for inflation, 2.63. And because that's hurting us, we're going to put that there. And then let's say we said we're going to do this for 30 years. 30 years times 12 months, 360 payments, 360 periods. Next, we've got $100,000. We want to see what the effect is on $100,000. How much is it going to be worth with this inflation over 30 years? We're not going to be making any changes to this, additions or subtractions during these periods. We just want to see what it's going to be worth. So now we calculate for the future value, and we see that our $100,000 is now worth less than half of that at $45,390. Goes to show, if the saying goes, if you're not making it, you're losing it. With the starting balance of $500,000, if I was depositing $500 a month into a checking account and was absorbing the losses from inflation, what would my future value be after 5, 10, and 20 years? Well, let's start with 5 years. Okay, let's say $500,000. And we're putting in, I'm sorry, that's got to have to be a negative. Okay, and we're putting in $500 a month. $410,000 at the end of 5 years. So even if we're putting money in, we're still losing money. So there's a point where you're going to break even. The amount of money lost due to value lost due to inflation is going to match how much money you're putting in. Let's do 120 months. Then there it goes, lower and lower. 20 years, same thing, and it's going down. So how much would it cost to break even? So simple as that. We just want to know how much would it cost us in payments to keep our initial $500,000. So we solve for payment. Almost $1,100 every month. That's how much you're losing due to inflation at $500,000. So next question is, how long would it take for its value to be cut in half? So we want to solve for n. So we have $250,000, zero payment. After almost 16 months, the value of $500,000 is cut in half. Interesting, huh? My investments to date through the online lending platform Lending Club has netted me an annual 13% return. So we'll use that as an example in most of these scenarios. The value of a $5 Starbucks cup of coffee on 13% return in 10 years, so that's 120 months, $5 present value, zero payment. What's that going to be worth? In 10 years, how much is a $5 Starbucks cup of coffee going to be worth to me? 18 bucks. All right. 20 years. That's 240. $66. Wow. Let's look at 30 times 12. It's 360. That $5 Starbucks cup of coffee with my 13% return, by the time I retire in 30 years, is going to be $241. That's amazing. Now keep in mind that doesn't count for inflation. So if you want, all you have to do is subtract 13 from our average 2.63%, and that's what we'll be making in today's dollars. So what is it in today's dollars? Okay, $110. That's a lot of coffee. So let's say you're in your 20s and you've got more time. It's 480 months, $310 Starbucks cup of coffee. How much would refinancing to a lower interest rate save me? Let's look at 340 months on a 5% return. Let's say that's what we're paying in interest on our loan. Let's say it's a $200,000 loan. Future value is 0. And we're going to solve for payment. So that's what our amortization would look like. That's what our monthly payment would be in principal and interest. Now, to find out, we want to look at the total interest paid. So we're going to go here, select the amortization, and we'll see the total interest paid is $174,000 over the course of 30 years. A little less than 30 years. Let's say I'm 20 months in on a 30-year loan. So let's go ahead and go back and look at refinancing it. So we're refinancing to a new 30 years. Okay. And let's say we refinance to 3.375%. So now we're going to keep the future value at 0 because it's an amortizing loan. Our payment is now only $884. How much is that in total interest? $118,000. 118 and change. That's a difference of $63,503. So in this case, I'd say it's pretty safe to refinance if I'm going to keep the loan over the entire duration. Let's look at the cost of credit card debt. This is really what's going to affect most of us since we have credit card debts at some point in our lives. Most credit cards charge somewhere around 18%. Okay. Let's say we owe $8,000. And let's say we're paying $200 a month. That's going to be probably your minimum payment on $8,000. With a future value of 0, because we want to pay it off, it's going to take us 61 and a half months, about 62 months to pay it off. It's actually longer than this, as credit cards compound interest daily, not monthly. That's quite a long time at 18%, huh? Opportunity cost of credit card debt. Total interest paid, we're going to go ahead and look at the amortization, is $4,308. So this is the cost, this is the immediate cost of the interest that you're paying. Let's look at the opportunity cost of that. $4,308 that you paid in interest. Let's say you had invested that at a 13% return over 30 years. What's the real cost of the interest you paid on that debt? $208,000. Makes you really think twice about keeping that interest debt, that high interest debt around, doesn't it? Now, mind you, this isn't exact, but it'll give you an idea of what we're messing around with here. Interest really does play a big factor. If we're looking at a 5% return on our money, it's a much different story. As it's compounded monthly, you really want to aim for a high interest investment, but you also want to manage your risk. So the retirement investing and withdrawal scenarios. One time, $10,000 at age 40 till retirement at a 13% return. 13% return. We're already at age 40, so we have 20 years, right? Let's say we retire at 60. That's 240. Okay, what's that going to be worth to us? $132,000 and change. It's not bad. Let's take a look at 30 years. That's 360. What's the time value of that additional 10 years? It goes up to almost $4,000. See, the sooner, and this is off the same amount of money. This is why it's not impossible to retire and start saving to retire. To start saving to retire at 40, but that additional 10 years really does make a big difference. Let's see what happens if you start working toward it when you're 20 years old. You manage to save up $10,000 and nothing else. That 483 becomes $1,762,000. Isn't that amazing what that additional 10 years will do for you there? It's compounding, and that's the beauty of it. Let's use N to solve for the future value to find out what an account should be at during any point in time. Let's say with this $10,000, we want to know where we can approximately be at in 92 months. 26,000, not bad. Let's say 200 months. 86,000. So as you can see, the value grows through compounding interest, and we can actually go through and see at any point in this amortization. It's really meant for loans. In this case, principal's being added back in. So really what we're just doing is looking at the balance. Isn't that crazy? This is per month. Alright. Let's look at the monthly contribution requirement to reach $1 million by retirement at age 50. So we only have 10 years, 120 months. We want $1 million. There we go. So we want to find out, let's say we have nothing invested right now. How much would you need to put in every month to get $1 million in 10 years at a 13% rate? Almost $4,100 a month. Now, let's see, if you started saving at age 40, you have 240 months to get to 60. Wow, only $882 a month. Now let's say you started when I started, age 30. Only $228 at a 13% rate to get $1 million. Again, we're not factoring in inflation here. So we can do 10.37, our calculation from earlier. Okay, so that actually looks right. In today's dollars, I would need to put in about $409 in a month to reach my goal. Now let's say some of you young ones are starting at age 20. How much would you need to put in? Only $141 a month. Some of you spend more at Starbucks a month than that. So we're going to solve for the present value to figure out what your initial investment needs to be for your retirement goal. So let's say 480 months, 10.37 interest, payment is 0. future value is $1 million. I'm sorry, present value is 10,000. We're going to solve for n. This is how many months it would take for you to reach $1 million in today's currency, values, I should say, off of $10,000. That's 44.6 years. Let's say we don't make as much. Let's say we don't want to take a lot of risk. How many months would it be? It's a little bit more. 72 years. Just not attainable at such a low return. So you're going to have to be careful. You really want to get that, keep a consistently high return. Now let's say you have it in a CD or your checking account or something, right? Not even 2.37%. That's, after inflation, that's like a, 5% return? Good luck. I don't think you're going to live to be 194. So that's really important that we maintain a high return, a consistently high return, or at the very least, towards the beginning, you want to really assume that risk and try to get a high return towards the beginning, because as time goes by, as you get closer to retirement, you don't need as consistently high of a return because you've already made a large portion of your money. Now we want to solve for interest rate. So let's say we're looking at 20 years and we have $10,000, right? And payment is 0. Yeah. And a future value of $1 million. What consistent interest rate would I need for at 20 years off of $10,000 in order to get $1 million? 23%. Now let's look at it at 30 years. 15%. Okay. 30 years, $10,000. I can make $1 million off of 15%. Let's do 40 years. 11%. 11 and a half. How much to draw down to 0 based on life expectancy? So you've already got your nest egg, $1 million. Let's make that our present value. Okay, now we've got a future value of 0. And let's say we're making, after inflation, 10.37. And we expect to live from the age of 60 to, let's say, 80. So that's 20 years. How much can I safely withdraw? About $9,900 a month at that consistent return. And once again, in the amortization, we can see where we are at in any step, all the way down to 0. So that's everything for now. Thanks for watching. I encourage you to try it out and share some interesting calculations. If you have any questions, you can reach me at googlemaster@outlook.com. Thanks again.